Now that we have those key concepts established, let's work our way up to a complete description of unit selection. The first thing we're going to construct is a target unit sequence. That's a sequence of the ideal units that we would like to be able to find in the database. These target units are going to be abstract linguistic things. They don't have waveforms. When we talk about the search a bit later on, we'll find that we want all the information about the target, about the candidates from the database, and also about the way that they join, to all be stored locally. That's going to reduce the complexity of the search problem dramatically. So let's do that straight away. So what the front end gives us is this structured linguistic representation. It has connections between the different tiers. It has structure. For example, it might have some tree shapes or some bracketing like this structure. We're going to attach all of the information to the phoneme tier. So we're going to produce a flat representation where all of that higher level structure, such as part of speech, is attached down onto the pronunciation. So what we've got effectively then is a string of segments. That's just a fancy word for phones, with contextual information attached. So context-dependent phones. So one of them might be like that, and it's part of a sequence. And in this example, my base unit type is the phoneme. A real system probably wouldn't do that. I'm just using it to make the diagrams simpler to draw and simpler for you to understand. I'm just going to move that to the top of the page because we need some room to put the candidates on this diagram later. What we have in this target unit sequence then is a linear string of base unit types, and each of those is annotated with all of its linguistic context. So everything that we think might be important for affecting the way that this particular phoneme is pronounced in this particular environment. It's essential to understand that this information here is stored inside this target unit specification. We do not need to refer to its context to read off that linguistic specification. It's local. I'm just going to repeat again that the base unit type in this diagram is the phoneme, just for simplicity. We could build a system like that, though we wouldn't expect it to work that well. In reality, we probably use diphones. That is going to make the diagram look a bit messy, so we'll just pretend that the whole phone is the acoustic unit, so the base unit type is the phoneme. There's our target unit sequence, and what we'd like to do now is go and find candidate waveform fragments to render that utterance. We're going to get those candidate units from a pre-recorded database. The full details of the database are not yet clear to us. That's for a good reason. We don't know exactly what we need to put in that database yet, because that all depends on how we're going to select units from it. For every target unit position, such as this one, we're going to go to the database and retrieve all the candidates that match the base unit type. So we'll pull all of the waveform fragments out that have been labelled, in this case with the phoneme schwa. Here's one candidate, the first one we found. And remember that the candidates are waveform fragments. They're also going to be annotated with the same linguistic specification as the target. That waveform is what we're going to concatenate eventually to produce speech. In general, and if we've designed our database well, we'll have multiple candidates for each target position, so we can go off and fetch more from the database. We'll get all of them, in fact. I've only got a tiny database in this toy example, so I just found 5. In general, in a big system, we might find hundreds or thousands for some of the more common unit types. And we're going to repeat that for all of the target positions. Let's do the next one. Now, it seems a bit odd to treat silence as a recorded unit here, but remember in the case of diphones, we're just going to treat silence as if it was another segment type, another phoneme, so that we can have silence to speech and speech to silence diphones, just like any other diphone. And we'll go off now and get candidates for all of the other target positions. So at this stage, I haven't applied any selection criteria at all, except that we're insisting on an exact match between the base unit type of each target and the candidates that are available to synthesize that part of the utterance. That implies then that our database minimally needs to contain at least one recording of every base unit type. And that should be pretty easy to design into any reasonable sized database. Right, where are we at this point? Let's orient ourselves again into the bigger picture. We have run the front end, got a linguistic specification of the complete utterance. We've attached the linguistic specification down onto the segment, onto the pronunciation level. And that's given us a linear string, a sequence of target units. And those target units are each annotated with linguistic features. They do not yet have waveforms. We're going to find for each target a single candidate from the database. So far, all we've managed to do is retrieve all possible candidates from the database, and we've just matched on the base unit type. So what remains to be done then is to choose amongst the multiple candidates for each target position so that we end up with a sequence of candidates that we can concatenate to produce output speech. And we're going to need some principle on which to select from all the different possible sequences of candidates. And of course, what we want is the one that sounds the best. And we're going to have to formalize and define what we mean by best sounding, quantify that, and then come up with an algorithm to find the best sequence. It's important to remember at all times that the linguistic features are locally attached to each target and each candidate unit. Specifically, we don't need to look at the neighbors. That's going to be particularly important for the candidates because for different sequences of candidate units, their neighbors might change. That will not change their linguistic features. The linguistic features are determined by the source utterance in the recorded database where that candidate came from. So the next steps then are to come up with some function that quantifies best sounding, and then to search for the sequence of candidates that optimizes that function.